Hey, this video is for Physics 1 students and it's about energy. The first sections in this chapter, Chapter 9, are on work and power. Work is done only when a force causes a change in motion. Okay, so you need two things for work to be done. You need a force acting on an object, and that object has to move. The force also needs to be in the same line as the motion. In other words, it either needs to be in the same direction or the opposite direction, which would be the same line. The equation for work is force times distance with the units of newtons, that's the units for force, and meters, the units for distance. 1 Newton meter equals 1 joule, which is the official unit for work. Power is the rate at which your work is done. There are other quantities that we've learned about that involve rates. That would be velocity, the rate at which distance is changing, and acceleration, the rate at which velocity is changing. Power, that should be an equal sign there, is work divided by time, or in abbreviated form, W over T. Units for power, joules over seconds, and 1 joule per second equals 1 watt. We've done several sample problems in class on power, which hopefully are in your notes. Some thinking questions. Two people weigh the same amount and both run up a flight of stairs. Do they do the same amount of work? Who would be the most powerful person? And if they are not the same weight, could the lighter person ever be more powerful? The answer to that question is, if they weigh the same amount, they do the same work. The most powerful person would be, if they weighed the same amount, the person that ran up the stairs faster. And if they're not the same weight, the lighter person could be more powerful if they ran up the stairs fast enough to give him a higher power rating. Remember, to be a power at school, you will have to work overtime. Get it? This is your homework assignment that you've already done, and you've already done the worksheets on work and power. Okay? Sections 9.3, 9.4, and 9.5. They are about mechanical energy, potential energy, and kinetic energy, respectively. After completions of these sections, you should be able to explain the relationship between work and energy, define potential and kinetic energy, and tell the difference between mechanical and non-mechanical energy, and give examples of non-mechanical energy. Energy is the ability to do work. It is measured in joules, just the same as work. Mechanical energy is the sum of potential energy and kinetic energy on an object. There are other forms of energy, and these we call non-mechanical energy, and they occur due to vibration of molecules, and they have kinetic energy because they're vibrating back and forth. It doesn't affect the motion of an object. In other words, water could be sitting in a glass and have non-mechanical energy because of the particles of water are vibrating back and forth, but that glass of water is not moving from point A to point B. Chemical energy is an energy that is locked up inside the bonds between atoms and molecules, okay? So when you eat your food, when you digest the food, you get chemical energy from breaking the bonds. When new substances are formed during chemical reactions, this energy can be released. Okay? Solar energy comes from the nuclear reactions, fusion, that occur on the sun. More forms of energy. Electrical energy results from movement of electrons or charged particles through a conductor, such as a wire. The electricity you use in your house every day is an example of electrical energy. Light can carry energy in the form of electromagnetic waves. Okay? Light energy in the form of you can feel, you can see the energy. These waves carry energy.